So hello everybody. So today I'm going to discuss about the superposition theorem. So first I will be discussing about the statement. So as per the statement, in a linear network excited by more than one energy sources, the overall response, that is the current or voltage across in any branch, is equal to the algebraic sum of the response due to each independent sources acting one at a time and with all other ideal independent sources set equal to 0. So that means when we will set an ideal voltage source equal to 0 means the source is replaced by a short circuit. Now setting an ideal current source equal to 0 means the source is replaced by a open circuit. So this is a voltage source and it has to be replaced with a we can say with a short circuit. So this is a voltage source replaced with a short circuit, and if there is an ideal current source it is replaced with a open circuit. We will see one problem. So here this is the problem. Find the current in each branch by applying superposition theorem. So the circuit consists of two voltage source, V1 at 24 volt and V2 at 12 volt. And there are three passive elements, so we can say passive resistances R1 of 4 ohm, R2 3 ohm and R3 6 ohm. So we will find out the current in each branches by using superposition theorem. So let us take the source 1 alone, that is the voltage V1. So when we consider source 1 alone, that is voltage V1, we will make the other source as a short circuit as it is a voltage source. So we will find out the net equivalent resistance of this circuit. So the equivalent resistance includes now R2 and R3, they are in parallel, and R2 R3 combination is in series with R1. So we will find out the equivalent resistance RT1, which is equal to R1 plus R2 into R3 by R2 plus R3, and we get a value of around 6 ohm. Then we will find out current I of 1, that means current in branch 1 due to source 1. So that is the total voltage due to source 1 V1 by total resistance RT1, that is 24 by 6, which is 4 ampere. Now we will go to find out the current through the branch elements like I21 and I31. 1 represents due to source 1, 2 represents the branch number like third branch, second branch and the first branch, and 1 represents the source 1. So we will find out I of 21, that means current in the branch 2 due to source 1, which we will use current division formula. So here as this I11 current is divided in these two branches, so total current I11 into opposite branch resistance by total resistance. So I21 equal to I11 into R3 by R2 plus R3. So we get an answer of 2.66 ampere. Now similarly we will find out current through branch 3, that is R31. So R31 equal to total current into opposite branch resistance by total resistance, that is R2 plus R3. We get a result of 1.33 ampere. Now we will consider step 2, that is we will take source 2 alone at a time, that is the V2 source. Now when we take V2 source, we will make V1 source as short-circuited. Then we will calculate the total equivalent resistance. So total equivalent resistance, when we will calculate in this circuit, we find that R1 and R3, they are in parallel to each other and the combination is in series with R2. Therefore equivalent resistance of the second case is equivalent to R2 plus R1 into R3 by R1 plus R3, which will give you around 5.4. So we will find out now current I22, that means current in branch 2 due to source 2. So I22 current is equal to V2 by RT1, which is 12 by 5.4, that is 2.22. Next we'll be finding out I of 12, that is the branch currents we'll be finding out, which is total current, same current division formula we will apply, I22 into R2 by R1 plus R3, opposite branch resistance by total resistance, and we get a value of around 1.33 ampere. Similarly, we will find out current in the branch 3 due to second source. So that is again total current into opposite branch resistance by total resistance, we calculate to be 0.88. Now by the principle of superposition, current in each branch I1 is equal to current due to in branch 1 due to source 1 minus branch 1 due to source 2, because the direction of the currents are opposite. So we get a result of 2.667. Now similarly in branch 2, that is the current due to source current in branch 2 due to source 1 plus current in branch 2 due to source 2, and similarly in case of the branch 3, here we are adding because the direction of the current is same in both the cases. So we can check it that I3 equal to I1 plus I2 which is 2 equal to 2.2218 ampere. So thus by the help of superposition theorem, using one source at a time, we have found out the current in each branch.